So today we will be continuing with dictionaries, and dictionaries won't take much time. Then we will move on to operators. Let me make a new file. And I've said py. Okay. So what are dictionaries? Dictionaries in Python. Okay. So dictionaries are a versatile and powerful data structure. Okay. Basically, they have a unique way of to be written. Every value inside, like for example, when we used to write list, sets, or tuple, we just need to add the items within brackets. Okay, in tuple we can write without brackets also, but in dictionaries we write as pairs. Okay, and they are called key value pairs. They're actually similar to sets in many ways, but have some distinct differences for which they are unique. So how how can we define dictionaries? uh, well, that you can figure out based on the characteristics that I am going to tell you. Okay, so the first thing is, it is a collection of key value pairs. Key value pairs. Okay, so dictionaries store data in pairs. For example, let me tell you, for example, I declare variable d and we write it using second bracket. So what does key value pairs mean? For example, we let's say we make a management system for a shop, dealership, and it's a dealership for mobile phones. Okay, and for say today I have ordered a certain number of phones for certain number of brands. So for example, if I have got Xiaomi. Okay, so I have brought, for example, or say ordered 20 pieces. Okay, items for Xiaomi. Then for say Samsung, I have got around. I have ordered 10 new pieces. Okay, like pieces in the sense, let's say products. Okay, 10 products of Samsung, 10 mobile phones. Okay, then for example, for I think HTC is no longer there in the market. Anyways, Huawei, for example, in my area, it's not much popular. So maybe I have around five, let's say 10 only. Okay, Samsung, let's increase it. It's always on demand. So that's 25, for example. Okay, suppose it's three brands and these are the value. Okay, so this here, this one is basically a key. Okay, to which we assign a value. Okay, for example, you can also make a system for like for your marks. For example, we have a student here, Geneva. For example, she has got her internal marks. Okay, internal result marks of the semester, and for example, for microbio, out of 100 she has scored 75. For biochem, she has scored around 80. Okay, and maybe she miserably performed very poor in bioinfo, as she has no interest in that. Maybe. Okay, just pass somehow. So you can like this you can make a management system where you are assigning values. For example, in your college management system, you can see your attendance. Okay, every day you can see the marks that you are getting in your regular assignments, in your midterms, end terms, okay, whatever. And then you can also see the number of some streaks, some contests, or whatever you are attending there. Okay, or placement, for example, placement management system, how many companies you have applied, or how many companies you have cleared some round one and all. So for all in all these concepts, a certain value has to be assigned to a key. So for that, dictionaries are very useful. So this is called collection of key value pairs. Second, they are unordered. Okay, what does this mean? It means they do not have a specific order. It can come in any form, like biochem can for come first or microbiome can come later. Okay, can be anything. Then these are all unique keys, which means, for example, once I have assigned 20 pieces, 20 products for Xiaomi, I will not be able to add another 50 to Xiaomi or another 5 to Xiaomi. Once what's done is done. Okay, so that so means it's not, I'm not saying we cannot change. We can change here. Okay, we can change this. See, but we cannot like add, like for example, add another Xiaomi product or something like that. Okay, for that we can do, but we have to name it with a different key value. For example, I might add there the name Xiaomi dash a product, particular product name and the number of pieces. Then that will become unique, that will become different. Okay, so unique, so unique keys, but yeah, values they can be same. You can order 20 pieces of Xiaomi and Huawei for both. Okay, then comes duplicate values. Now this means these the keys must be unique. Xiaomi, Samsung, Huawei, these are unique. But yeah, these values, yeah, they can be repetitive, no issues. They can be different. Okay, and you can actually write it in the reverse order also. It's not like it is string first and then followed by a number. For example, you are adding name of students, assigning students to their unique ID or say roll numbers in a college. For example, 101 is my roll number or my unique ID. Okay, then say 120 is assigned to Alia ma'am here. Then say 105. Oh, sorry, 105. It's assigned to Jeet here. Okay, and then we have an for example 125. We can to another student. Yeah, done. So we can add like this also. Okay, now the concept that I am saying is not like it is only used for this purpose. What I am trying to say is I am trying to make it relatable. Okay, so that you can understand the use of this dictionaries. Okay, and finally hashing, uses hashing internally. Now what does hashing means? So they use a hashing mechanism, which you will learn actually in advanced data structures. Okay, that I'll teach later. Okay, they have a certain mechanism to store and retrieve data efficiently. So this is basically like used for storing and means that's a general concept. I'm not going in deep into this right now, but just for theory, knowing the theory sake. Okay, let's say retrieve data efficiently. Cool. Yeah. So that is that means uses hashing internally. Okay. Now for now, since I have showed you what are how to make a dictionary, here let me add this Xiaomi etc. These are the keys, while this 20 comma 25 are these are the values. I hope you are writing simultaneously. Okay. So these are our dictionary. Now I have shown you how to create and use a dictionary. Now okay, for example, you want to create a dictionary from scratch. For example, let's say uh, let's declare variable, and this is how you create an empty dictionary. Now how to uh, you know insert items in this. Okay, how to create a dictionary from scratch. Okay, for that we will use this method. For example, let's say I am assigning costs of certain products. Okay, in an electronic store. Okay, let's say I have an electronic store where I keep mouse, monitors, laptops, mobile phones. Okay, So I am assigning the cost as here laptop 40,000. Okay. Again, for example, I have mobile phone 15,000. A, let's say earphone. Okay, earphone. Here we assign value as 2,000. Whatever. So third one will be. We have very high quality ones. Anyway, now let's print A. Okay. Now listen, I have used print A only for this A, which means it will not show the value of D, A, M, S or anything before. Okay. Oh, sorry, I have forgot to delete these terminals. Yeah. See, it made a dictionary. It has assigned the values dictionary A. So this is how you create a dictionary basically. And for say, if someone asks you the real world examples, which I said you, but let's say add here. Okay. No, I'll add it up here only. Okay. Say real world applications. Okay. For example, one can we if you want to make a word dictionary. Okay. Suppose you want to assign a particular word to a particular page of a dictionary, okay, something like that, then employee directory. Uh, let's say in healthcare database for genome, healthcare industry, genome database, okay, in biotech for then for say in cyber forensics or some not cyber forensics in forensics for they can make a DNA database used for DNA analysis. Okay, so genome database, DNA database, almost same thing. Okay, let's do it. So yeah, student management system, student data management. Okay, learning management module or something like that. Okay. Anyways, these are some common applications of dictionaries. Okay. So give me a second. This was all about dictionaries. Okay. It was really small. Basically, there is not much application. Yeah, most of the we do not usually use dictionaries in most of the cases, only except we are developing a system. So if we do a project where I will develop something live here, I'll show you the use of dictionaries there. But apart from that, I don't think it's worth wasting time, you know, on something that we are not gonna use regularly. Okay. In fact, in data analysis also we mostly use lists. Machine learning also we mostly use lists. Okay, so list is something that I will take another class in a very detailed manner. Okay, we will go into its applications, how it is used and all. Okay, for now we will close this and start with operators. Cool. Okay, before that, any of you have any doubts?
No,
Anyone?
no, sir.
You can tell in the chat box also. Any doubts? Then we can move ahead. Guys, am I audible? If no doubts, at least say no.
You can move ahead.
No doubts, okay. Clear. Go ahead with. Now we will start operators. In operators, shit, start. जो भी. Anyways, so in operators, what are operators? Basically, operators are uh, when we have to do functions like, for example, addition, multiplication, or say finding uh, whether something is present, okay, any item is present or not in a particular data type, okay. So the operations that we perform on the data types, okay, for that we use operators. And the first that we will deal with, okay, before that, let me tell the operators that we will be doing. Types of operators. So first we will go with arithmetic operator, small one. Then logical. Then we go with membership and identity operators. Bitwise operators. So this one is a lengthy one. I have to teach a lot of things. So this one we will do actually at last. Okay. Most probably by tomorrow. Today we will just finish rest of the things. So then arithmetic progression. So this is not an operator. Is basically the thing we will be doing. Okay. An active arithmetic progression, geometric progression, then sum of natural numbers, and find last digit in Python. Good. Okay. Let me just put my system in charge. Let's start with arithmetic operators. Arithmetic operators. I have not used. So in arithmetic operators, we have seven main kind of operations that we do. One is addition, one is subtraction, okay, then multiplication, then division, then modulus, which means modulus means to find the remainder, okay. And by this method we actually determine even, odd, or prime, composite, and all those things. Then the pair, okay. Then float division. I'll tell what is float division. Before that, give me a minute, guys. Just I'm coming in a back. Call is coming. Just give me 2 minutes. Okay, thank you guys for giving me 2 minutes. Okay. So see, this is basically arithmetic operators are really easy. Okay. It is simply let's say I first just in give two assign two values here b is equal to 4. So for add we'll simply do print a plus b. Okay. I'm not printing anything right now. Just I'll show you. We should not waste time on easy stuff. Okay, anyone can do this. Even you can like do this close by one eyes closed. Okay, multiply print a by b. Okay, then say division. Then say division. Print a slash b. Then say modulus, right? Print a modulus b. Or say b modulus a because in this case 4 divided by 2 we will get the result actually. Yeah. Anyways, then for example exponentiation order. Okay. I don't think I have added the exponential order. Yeah, exponentiation order. Just watch. Exponential order. Cool. Okay. Expo. So for that we simply use print a star star b. Always remember you do not use this. Okay, this is for this is another purpose. We use this symbol. Okay, and then float division. So what is float division basically? It finds the floor of the quotient when the first operand is divided by the second. Okay, so if we find this by using say b slash slash sorry slash slash a. Okay, save. Let's see what we get in each. Okay, see, this is addition, subtraction, multiplication, division, modulus. Modulus means you find the remainder. So 4 divided by 2, the quotient will be 2, but the remainder will be 0 as it is divisible. Then 2 to the power 4 exponential order 16, and finally 2 b slash slash a. It means it will give float division means it will always give the integer value, okay, of the quotient. So it will round up and give the integer value, okay, so of the quotient, no, not the remainder here. Okay, so this was arithmetic operators mainly. Okay, now we should know two important things: precedence and associativity in arithmetic operators. Okay, say precedence and associativity. Associativity. Cool. So what is precedence and associativity? It means the order, thus the order in which we perform the particular operation. So here, what it actually determines, for example, let me give you a proper statement for this. Operators precedence determines the order of order in which operations are performed in an expression. Cool. So operators with high precedence are evaluated before with those of lower. Okay. So the order in which we do this is first comes exponentiation, okay. um this one followed by in this particular format, multiplication, then division, then floor division, then modulus, okay, then addition, sorry, addition, finally subtraction comes at last, okay, in terms of precedence. So if we do a complex calculation, for example, let's say 5 plus 3, sorry, 3 multiplied by, it's 4 exponent. Now let's add some exponentiation 2, okay. What will happen according to the uh, order, the precedence order? First it will calculate 4 to the power 4 square, so it will be 16. Then it will take the multiplication, so 16 into 3, and then plus 5, okay. So answer should be 40, sorry, 48 plus 5, 53, right? So let's see if it gives the value or not. 53. So I hope you have understood the order of the precedence. And lastly, operator associativity. One is left to right and right to left. Let's add a separate. So here is the order precedence. I'll add, no, I'll add separately. Order associativity. Okay. So for example, let me put this associativity. Associativity determines the order in which operators of the same precedence are processed in an expression. So it is of two types. One is left to right and another is right to left. Now, which one we use when? Okay. First, if you take left to right, so when there are operators like addition and subtraction, it is we always take it left to right associative. Okay. So I'll just write in short. Okay. In this case, we always take it left to right, but when it is right to left, okay, that time the other operators, for example, when exponentiation comes and other all those multiplication and all they come, they are usually taken in the right to left. So let's do two calculations. Print 5 plus 3 minus 2, okay. So in since we are taking, in this case it is plus and minus addition subtraction, we take it left to right. So for example, we will do 5 plus 3, then minus 2, 6, 8 minus 2, 6, okay. And this one is to right, and another is print, let's say let's do complex one inside another bracket, 2 2 square, then another time I am giving this, that is 1, okay. In this case we will go right to left. Okay, before I do it, anyone wants to predict the answer, you can write in the chat box. This one, anyone who wants to predict the answer, tell me. Anyone who wants to predict what will it give? Okay, let me give someone more also. I will not say, you will only calculate. Others, uh, print. Okay, give me answers to all three. I'll wait, and I will not move until this is done. Yeah. Geneva, are you doing? Jeet, would you like to press? Yes, yes, okay. Jeet, would you like to present your screen and explain? Anyone who wants to explain? I won't say which one of you is correct and which one of you is wrong right now. I want you to justify your answer. Come on, don't waste the time, please. Just anyone can volunteer. I will stop sharing my screen. Then only I will move forward. Anyone can come up and justify the answers. Tell the answer and justify, and others will tell whether it's right or wrong. Then I'll go to the next one. Because only bitwise operators will take time. Others are very easy. Logical operators, AP, GP, they're just formula based. So I have no problem waiting. It's please anyone can come up. Tomorrow we can complete with bitwise operators and go ahead with conditional statements, flow control, and loops will take 2 or 3 days. Then we will run because that will mark the completion. After that, function, string, list is all dependent on what we have studied till now. Oops, advanced Python concepts will they are all dependent on what we are studying now. Till loops, it is all independent concepts. From functions, it all depends. Then we can run. Okay, anyone, Jeet, Geneva, Ali, ma'am, anyone can please present a screen or just justify the answers. Yeah, go ahead, Jeet. Okay, yeah, of course, the compiler will give you the right answer. Justify. Tell me if you are doing it manually, what are you following? What rule are you following?
In case of manually,
Yeah.
first 2 exponent of 2,
Mm-hmm.
that will be 4.
Mm-hmm.
Uh, is then exponent of minus 1, that means it is 1 by the result. So 1 by 4, that will give 0.25.
This is which one?
The first one, 2 exponent of 2 exponent of minus 1.
Yeah, yeah. Uh, Wait a minute. You have given the brackets part. This is basically yeah, yeah, 0.25, right? Yes, and the rest and next two,
Yes,
uh, next two actually answers for both of them are same. So just do either one of them.
okay.
Yeah, just do either one of them. Just in the result part. No, no, present the screen and do it. Yes. in
Oh,
front.
okay.
Yeah.
Are the answers for the other two 2 to the power 1 by 2 or under root 2?
Yeah. 1 by root 2 will be the answer, and in decimal it will be 1.41. Anyways, Jeet, let's do it. Then we will start with Python logical operators. Very easy thing. Just copy paste what I've given in the chat box. The result in second bracket it should be out of quotes. Rest you have done correctly. That thing will give the output correctly.
Okay.
Yeah. What happened?
Let's see.
Syntax error. But oh yeah, you have to give a comma after quotes.
It is perfect.
Yeah, right. Now run. See, the easiest way to always, rectify yourself is to read what error it's giving the platform. It will always tell you whether it's a syntax error and what you have to do then. If it's a type error, then what you have to do then. Okay, it will always give you the solution. Okay, you just have to read it carefully. What kind of error it is showing and what are they suggesting? They always suggest some solution somehow. Okay, so if you're and if, even if you're not able to understand the if you're able to understand what kind of error it is, but you don't know how to solve the error, you can definitely search some platforms, okay, which for example Stack Overflow, very famous platform for solving coding problems. ChatGPT is always there, of course. You can do that also, but yeah. Anyways, so I think you all have understood this part. Please just say yes or no. If any doubt you have.
Yes.
Yes, we
Here
are
I
understood.
wanted to ask in the print option, why are we writing the result in curly brackets? Like if I don't put the curly brackets and just write result after comma,
Yeah, it will give the answer.
it okay. So the curly brackets are not necessary.
No, 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 no. See, Python
Okay.
syntax is very, flexible. You just have to give the first bracket there. Inside it, you can write however you want. No issues. Okay.
Okay.
Yeah. See, because since Jeet has written in curly brackets, he has also got the answer in curly brackets. 1.4142. Okay. Now if he removes the curly brackets, he will only get the integer value. Okay. So yeah, Jeet, you can actually also, if you write result is equal to then int, then inside first bracket, then it will only give you the integer value 1. Okay. Like that it also gives. Anyways, uh, let's move on
No,
to the
but
next.
in the
Yeah,
first,
yeah.
sorry,
Yeah,
in
yeah,
the
tell.
first expression,
Yeah.
there also he wrote result in curly brackets, but
Uh,
in when he ran the same program, in the answer there are no curly brackets that I can see.
let's see. If
Um,
the result of the early expression is oh, oh yeah, it doesn't always show because see it how the platforms work. It's mysterious. Okay, honestly, no, neither me nor anyone has the exact answer. But honestly, you don't have to use the curly brackets. You can write without the curly brackets. It's better. Okay,
okay.
yeah. Also, yeah, one thing I can say inside, if you're writing inside the quotes, okay, then curly brackets is there, yeah. But we outside you may not need the curly brackets, okay. But then you have to use a comma also. So for that, and you have to write an F. So that will basically, that is increasing your complexity also. That you have to write an F in the beginning, then quotes, then you write using another curly brackets inside. No need. Just you simply write print and then the calculation 2 square and to the power of that -1. So yeah, okay then then I think I can move ahead with logical operators, right, guys?
Yes.
Okay, cool. So this one arithmetic operators. The operators here only. So, uh, no, I just add another LOGOps. Cool. Okay, so here we will do logical operators. So in logical operators, the name itself suggests we are using these operators for uh, you know finding out if some for a condition, okay. And these are mostly used in the flow control, okay, to in if else statements. So logical operators are mainly used to combine Boolean expressions. Now, what is that? What does that mean? That means we get the output in true or false, which means we check some particular conditions, okay, and then we answer and we get the output in true or false. So, for example, let's say, yeah, let's take you people only. Uh, I am assigning variable to each of you A, B, C, G, A, Geneva, B, Alibam, C. Okay. For example, C is present in bioinformatics class. Okay. And also present in and C present in Python class. Print, then print true. Okay. Which means they are present in both. Okay. And but let's say I use odd, present in either of them. Like for example, you're not able to do both the classes together every day. But let's say you are attending one day you're attending bioinformatics, one day you're attending only Python. So I'll say A present in bioinfo or A present in Python. I don't know where he's present, but he's present in either of them. Okay. So in that case, if the first one is true, okay, it will check for the next one. If both are true, then true. If one of them becomes false, then false. Okay. Let's say you are not present in either of them. Okay, then let's say A not present in bioinfo and A not present in Python. Okay, print refund. Like if someone is not present and not doing any class, there is no point. Okay, so that's how. Like print false. Okay, refund. I'm just joking. Anyways, so what it uses, let's write in theory a bit of theory in Python. Okay, logical operators are used to combine Boolean expressions, Boolean expressions, and the primary type are the primary types. Okay, the primary logical operators are,
Excuse me.
yeah,
Your screen is not visible.
oh, I stopped sharing. No, sorry. Yeah, thanks for telling. Yeah, so, visible now, right?
Yes.
Okay. Yeah. So I just wrote yeah, I just wrote in Python logical operators are used to combine Boolean expressions. Okay, and the primary logical operators are, one is AND, which is logical AND here. Okay, and OR, which is logical OR. If you remember, mm, when we were studying physics in 11th or 12th, I don't know exact which class, we were studying about logic gates. There we learned about lot of gates, XOR, or something like that, right? Logic gates. So there also these concepts were used a lot. Okay, and basically these operators, logical operators, are mainly used in those kind of conditions only. In basically, for example, flows. Okay, for example, you are making a system. For example, you are making a healthcare database system. Okay, so in that, uh there are a lot of checkpoints based on which we detect diseases, okay, on biomarkers, biosensors, okay. So we will apply logic, okay. For example, the a particular symptom, for example, if it passes this checkpoint, then it goes into this checkpoint, okay, and we create a flow until we get until we get the final answer. So the pathway, the route of the code or the logic, where it will, all of them will be true, all of them are like passing positively, it will indicate to a particular symptom. Maybe it's nothing, maybe it is no disease, maybe it's just a normal common cold, or maybe it's a serious disease, okay. But that will be determined based on the logics you are applying, okay. Like for example, we are in a system for you used for prediction, okay. I will build, when I'll be doing the machine learning classes, I'll show you, for example, building models, or say using predictive analysis to detect Parkinson's disease, or say Alzheimer's disease, or say heart disease, okay. We use a lot of logics. Sometimes we might use logical operators also if needed, okay. So and finally, not, okay, logical not, cool. Okay. So the basic logic, so let me just declare some values first, then I will show you how it is done, and two important tables to follow. Okay. So for example, I have declared three of them. Okay. So let's say print A less than B, and A, sorry, B less than C. Okay. C. I'm not printing it right now. I'll write another two statements. Say A less than B, or B greater than C. Okay. Then print not A greater than B. Okay. So let me first explain you what this means. First statement, we are checking A, whether A is less than 20. Sorry, 10 is less than 20. Of course it is. And B is less than C. 20 is less than 30. So since both the conditions are true, of course it will give an output true. Okay. I'll show you right now by running. Next one. A less than B, of course, is true. Or B greater than C. But it's this one is not true, right? When it comes to OR, it first checks the first condition. If it's true, only then it will go to the next condition to check if it's true or false. If both of them are true, only then the output is true. If one of them is false, for example, the first condition itself is false, then it doesn't matter if the second condition is true or false, the answer will be false in case of or. In and, okay, it happens the opposite and not, yeah. So a greater than b, 10 greater than 30, it's false. But since it's not, it will reverse and it will give you true. Okay, let's see. Sorry, in or, basically, one of them true, it will give you true. Okay, I'll just make the table. Yeah, so three of them are true. Let me just make the table and show you. Where can I make the table? Okay, we cannot make the table inside this, right? No issues. I'll make a doc and show you, for example. Oops. So okay, docs dot new. Okay, docs dot new. Okay, let's insert a table here. 3 into 5. Okay, first one will be expression 1. Okay, this one is basically truth table for and. Okay, then expression 2, and then the final result. Okay, okay, now for example, the result of first expression is true and the second one is also true, then it will give the result true automatically. Then another case, for example, first expression is true, second expression is false. I'll make materials and send you in the group, so you don't have to worry. Okay. Then- or you can, but meanwhile I would say make notes for yourself too, that I'm saying here. Okay, false. Okay, so in the truth table, if both of the expressions are true, the result will be true. One of them true and one is false, it will be false. Okay, same this case, false. Both are false, obviously false. Now let's say, just copy this and I'll make for or. Okay, okay. Now here, this both of them are true. It will be true, of course. In case of or, this will be reversed. If one of them is true, it will be true. Okay, and obviously if both of them are false, it will be false. Okay, and finally, see, for not, it is not true means false and not false means true. It's just the opposite. Okay, so this is basically the logical operators, and I'm not going deep into the logical operators right now today because this we will do using flow control, if else, and checking even odd. So those practical using those practical questions, you will understand better the logical operators, because nothing deeper is there in logical operators. It's not much of rocket science. Okay, so okay, this was, I mean, yeah, today it's 9:30 again. Time is over. Tomorrow we will do bitwise operators and these questions. It will these questions, arithmetic, geometric, sum of natural numbers, and find last digit in Python. This will take at most 15 minutes together, and bitwise operators it will take time. Okay, around half an hour at least it will take, because I have to teach you conversion of few conversion of binary into normal language or English, maths, and all. So that will take time. Okay. Okay, guys. So this was all for today.